Hello, today we're going to be doing an introductory lesson to rotations. I encourage you to look in your text. This would be lesson 9.4 in your textbook and look those over. The main point would be to see how the algebraic rules are developed for rotations today, kind of investigating how they are created. So let's go ahead and take a look. At a little note sheet here we have on rotation. All right, make this a little bigger so we can see. All right, with rotations, the first thing that you need to keep in mind is that when we talk about a standard direction for rotations, we're talking about counterclockwise. So you have two different directions that you can move, clockwise or counterclockwise. Clockwise would work like the second hand of a clock. So if we made the origin on this graph, okay, kind of here, like the second hand, okay, clockwise would be moving, okay, this direction, okay, as the second hand would move around the clock. Counterclockwise means it moves the opposite direction. So it could start here and then it would move, kind of like if it was moving backwards on a clock. However, what you should notice is that when moving this direction, you're following your quadrants. From quadrant 1 to quadrant 2, to quadrant 3, to quadrant 4. Now, the other thing I want you to pay attention to is the signs of your coordinates in each of your quadrants. If you have a point located in the first quadrant, the x-coordinate's positive, y-coordinate's positive. But any point that you move to in your second coordinate is going to have a negative x-coordinate and a positive y-coordinate. In the third quadrant, your x-coordinate's negative and your y-coordinate's negative. In the fourth quadrant, the x-coordinate's positive, but your y-coordinate is negative. Okay? Always check to make sure your signs match up once you have your construction complete for a rotation. Now, when we talk about a 90-degree rotation, 90 degrees is moving one quadrant on your graph. If you look at your XY coordinate plane, okay, the first quadrant makes a 90-degree angle. So just keep in mind, if you're rotating or turning 90 degrees, if you start in the first quadrant, you're going to move to the second. Okay, you've moved 90 degrees. To be able to do that, we're going to follow this procedure. We're going to switch our x and y coordinates, and we're going to check the quadrant to determine the signs of what those coordinates should be. So in our example here that we're going to draw up, we're going to rotate triangle ABC 90 degrees and give the coordinates of that image. Okay, so you've got the pre-image points here. We want the points for our image. So let's just start with A, just so that we see one point. A would be located at -2, -2. Okay, there's point A. Now, what we want to do is we want to move 90 degrees or one quadrant. So we know that it's going to move, if we move one quadrant, to the fourth quadrant. So I know my x-coordinate has to be positive and my y-coordinate has to be negative. So what I'm going to do is switch these two values. Well, 2 and 2 is still going to be 2 and 2. Okay, but now if I know I'm in the fourth quadrant, the x is positive and the y will become negative. Okay, and then I'll plot that. 2, -2 would be right here. A prime. Now, what I want you to recognize is exactly how that 90-degree angle is being created, because it's rotating 90 degrees. So if you were to take A and connect it to the center of the graph, which is the origin, and then connect to A prime, you're going to notice that we rotated or turned that 90 degrees total. So there's the 90-degree angle. Okay, so let's try with another one. B is at 4, -1. oops, -1. Okay, so there's B. All right, we're going to switch those. So I'm going to put 1 and 4. And now B was in the 4th, so it's going to move to the 1st, which means both coordinates should stay positive. So B prime will move to 1 and 1, 2, 3, 4. There's B prime. Okay, C was at 1, -5. So 1, 1, 2, 3, 4, 5. There's C. I'm going to switch those. So 5 and 1. But now, if I was in the 4th, okay, I'm going to move to the 1st. So both are positive. So 5 and 1. There's C prime. And I'm going to try to do these triangles in different colors so you can kind of see the rotation here. Make sure that this kind of worked out. So A to B to C was my original triangle here. Okay, there's the pre-image in green. And then A prime to B prime to C prime. Okay, you've got your triangles here. So you should see that we took one triangle, okay, and you move it, okay, 90 degrees. So, oops, I could have covered that up. A to A prime. Okay, B to B prime. C to C prime. Okay, when you're going to set that up. 1, 2, 3, 4. Oops, that's why. It looked a little skinnier, and that's because I didn't move C prime over quite far enough. I didn't count that. There we go. Okay, so there would be my triangle rotation. And you should see that the triangle itself is turning its orientation there. But if you took one and placed it on the other, this is still going to be a rigid motion. Meaning your pre-image and image are congruent. Okay, when you go to work that out. All right, now if we decide we're rotating 180 degrees, you're going to negate both x and y. Negate, add a negative, or make it the opposite sign. So make sure that you do change the signs of your original vertex. Okay, so in this case, if A was at 1, 3, then if I negate those, it would A prime would be at -1, -3. If B was at 2, 0, B prime will be at -2, 0. There's no negative for 0, it just stays 0. And if C was at 5, 2, it will become -5, -2. Okay, let's go ahead and take a look at that. A at 1, 3, B at 2, 0, and C at 1, 2, 3, 4, 5, 2. Okay, here's my original triangle. And then if we then graph the image, -1, -3, -2, 0, 5, -2 over here. I'll put this one in green just so that we see different color. Okay, and it should look like the triangles turned and they moved exactly 2 quadrants. So if we start here, okay, with our triangle in red, it has moved 2 quadrants, or 180 degrees. You should also recognize that 180 degrees is a line, or a straight line. So if we were to connect corresponding vertices, they should line up in a straight line with the origin, or with the center of your graph. Okay, that's easy to see with B and B prime because those are on the x-axis. They all line up. But if we were to take C prime, the origin, and C, you can see that these all line up, okay, in a straight line, which is 180 degrees. So you've taken C, which is located here, and rotated it 180 degrees, okay, to right here. All right, and then our last common rotation we're going to look at is 270 degrees. So when we work with 270 degrees, we're going to do both of the options that we just did with 90 degrees and with 180 degrees. Okay, so we're going to switch the x and y coordinates, and we're going to negate those signs and take into account what quadrant they're located in. Okay, so for instance, if we were going to start with, let's say, J at 1, -4. Here's point J in the 4th quadrant. We move 270. We're going to move 1, 2, 3 quadrants. So it's going to end up in quadrant 3, and I need to switch my coordinates. So quadrant 3 has negative and negative coordinates, and we need to switch those. So it's going to be 4 and 1 if I switch the 2 values, and then I make them both negative. So 1, 2, 3, 4, -1. Here's going to be J prime. K is at 5, -1. Here's K. And again, 4th quadrant. So it's going to move it 3 quadrants over, so to the 3rd quadrant. Switch my coordinates here, so that'll become a 1 and a 5. And both coordinates are negative in the 3rd quadrant. So -1 and 1, 2, 3, 4, 5. There's K prime. Okay, so line segment here, rotated to line segment here. Now, if you were to connect those, okay, together, you should see a 90-degree angle going clockwise, which an entire revolution is 360. So 360 minus 90 would leave us with 270 as far as that rotation goes. Now, that's what they look like on the graph and finding some of those coordinates. Okay, the key idea is to kind of take those rules now and create an algebraic rule that we can follow. So if you see a 90-degree rotation, you're going to take a vertex at AB and rotate that to -BA. So switch them and make the original y coordinate the opposite side. Okay, if you're rotating 180 degrees, vertex AB is going to move to -A, -B. We negated both of those coordinates. But keep in mind, if it's positive, it goes to negative. But if it started out as negative, it will become positive. Okay, so the negate works both ways. And 270 degrees, would have a rule at AB rotating to B negative A. All right, please keep in mind, this is just an introduction to rotations. Review your text and review lesson 9.4 before starting your assignment.